Welcome to a new video in the corrosion series. Today's topic is coatings for rebars. This question was asked in the WhatsApp group when I shared an article about the basics of concrete corrosion. So the question was, how can we protect the rebar in addition to cathodic protection and the coating? So I thought I'll just make a video about it. So concrete and corrosion rebar is basically twofold. So in this case, you have a reinforced steel bar inside a concrete, and this is supposed to act as the strengthening part of the structure. Now this concrete is exposed to the environment where there will be carbon dioxide, water, salt, particles, dissolved oxygen, and the concrete may not always be intact. Rather, it is never intact. It always has pores in it. It is through these pores that these elements will move inside the concrete. Now the issue here is H2O, O2 and NaCl may not react with concrete chemically, but CO2 will definitely react with concrete. It reacts with the concrete contents of calcium sulfate and it forms calcium carbonate. So basically the pH is changing to a huge extent and is becoming more acidic. Rather, the pH value is reducing, so it is becoming more acidic. Now because now the chemical structure of the concrete has completely changed, it is much easier now for these elements to move through and interact with this steel rebar, as is seen in the other steel components. It is the Fe will readily react with the H2O and oxygen to form ferrous oxide, ferric oxide, Fe2O3, and the NaCl will also react to form the ferric chloride. So this will start causing corrosion of the concrete. So now here this was the first part of the concrete degradation. This was the corrosion of the rebar is the second part of the rebar corrosion, and the third is that part where you have rust layers formed on top of the rebar. So you have a material loss and you have a rust layers formed. When you have rust layers formed, they will exert some stress from the inside, and this stress may cause cracking of the concrete at that part. So this is the third mechanism that occurs in concrete and rebar corrosion. Now how do we actually protect it? The usual methods used in the industry are listed over here. So because concrete is the main source from where the elements will go inside, concrete is usually coated with organic coatings or cement based coatings. So this may act as the first barrier to the ingress of the elements. Now cement based coatings basically will have a better interaction because they will be chemically similar to the concrete. So concrete will mostly have some kind of a coating to protect them as a barrier, but that may not always act perfectly, so we need another protection to the rebar. There are two ways in which the rebar is protected, either by cathodic protection or by coatings. Now when you have cathodic protection, you basically connect the rebar to an anode through some kind of a rectifier. So this rectifier ensures that this anode will be situated near the concrete, and this will ensure that the current or the electrons are provided continuously to the rebar. So the rebar will have Cp currents flowing from the anode. Now because from the rectifier the rebar has now become negative, so the electrons are flowing to the rebar. So even if the H2O and oxygen come in contact with the Fe here, the Fe already has all the electrons. It will have electrons, and the H2O or oxygen will not be able to provoke the dissolution of Fe. So the Fe will remain intact on the steel bar. So that will protect the steel rebar from corrosion. Now if there are huge structures, it is not really possible to put a rectifier everywhere, because the amount of money spent on this rectifier will be very, very huge. Also, if you have galvanic cathodic protection, also the cost will be a lot. Hence, the other method that is used is coatings. In coatings, you may have hot dip galvanizing, or you may have epoxy, or you may have this concrete polymer coating, which has been developed by the SICRI organization in India. This is a popular coating which is being used in the Indian industry for a long time now, and it is you can check it out on their website as well. So these consist of a composition of concrete and polymer based coatings. Then they will have two layers of the polymer based coatings. Here you will mostly have one layer. The hot dip galvanizing is very similar to what is done in the other industries. So you will have the concrete rebar, and you will dip it in the molten zinc, and you will have a zinc layer on top of the rebar. So even if you have a scratch, the zinc will give a sacrificial protection, which means that the zinc will corrode in presence of H2O and oxygen instead of iron. Only when the zinc protection is not enough, or the zinc has completely reacted out, then the reaction of Fe will begin. The epoxy is a single layer coating usually, which is liquid coating coated on top of the rebar. Now there are a few issues with the coatings that are done. The issues usually, if it is cathodic protection, then the issue may be the potential measurement and the connections. So if the connections are not good enough, or if there is a small if the connections are made internally, and if there is a small breakage, it is not possible to detect it all at the moment when it is broken. Only when the protection is lost completely and there is some indication outside, then the connections may be checked, or sometimes it is not really possible to check the connections at all. This usually affects the protection potential. So the potential that is measured using the multimeter to check whether the potential is enough is not always possible. You may check, it may be checked wrongly, or you may feel that yes, the potential is correct, but it's not actually correct. So that is one issue that is present in the CP potential methods. Usually there will be some measures in the companies to address these connections, but they are specific to those specific companies only. They will have everyone will have their own methods to check for this potential measurements. Now the coatings is something that I would like to really talk about, because the epoxy coating that I mentioned previously is banned in some countries. So the reason for banning usually is related to how the coating is present. So the coating compatibility is important, and the most important part is the surface preparation. The surface preparation of rebar may not always be possible, because although I've shown it to be a straight line, a rebar will usually have these kind of threads. So the surface preparation is not always done, because that may destroy the threads as well. And if the surface preparation is done over here on the flat parts, then the edge or the nooks near the threads remain unprepared all the time. So those may act as there the coating adhesion may not be really good. So surface preparation is really important. Also, the surface preparation methods may change with the rebar size and shape. So if the surface only one method is applied to all of them, then that may not really be correct. You may so that may also be one of the reasons why you may not get the correct surface preparation. If the surface preparation is not correct, then the coating compatibility or the coating adhesion with the substrate is not good enough. Also, if the coating is not compatible with the concrete, then the adhesion between there may be some repulsion, microscopic repulsion between the coating and the concrete. So the adhesion that is expected between the thread and the concrete may not really work. The next is this rebar structure, which basically is this threads. So if you have a coated structure, then the threads will always have some issues with the coatings, because they are high stress regions, and the coating, if it is done by hand, then there is some chance that you may try to coat it properly, but otherwise it is very difficult to get an even coating on the rebar, on the edges also. Sometimes also, if you use polymer coatings, then these threads, which usually will have some kind of zigzag structure, will get blunted out because of the coating layer. Because now they are blunted out, the adhesion between the upper concrete and the underlying thread is now completely lost. So you will lose the adhesion, that is, or you will lose the mechanical locking that is expected between the concrete and the rebar structure. Once you have these kind of issues, then if even though you have a coating on the concrete, there may still be some ingress in moisture in the coatings, through the coatings, or if there is some issue or some scratch in the coating, so these moisture and dissolved oxygen will still reach the substrate, and here the moisture will interact with the coatings to cause coating debonding. This is the major issue, because coating debonding inside the concrete is very difficult to detect, and once it is debonded, you have completely lost the coating, leading to corrosion underneath. The corrosion will lead to stresses as mentioned previously. Also, this kind of debonding will also prevent the CP currents from reaching the substrate as well. So that is another issue that may cause problems with the rebar corrosion. So there are methods to prevent corrosion of rebar, but you have issues with those corrosion as well. So the best way is to select the correct corrosion prevention method, keeping in mind all of these issues, rather than just looking at the how good the coating is, or what are the great properties of cathodic protection or the coating. Please keep in mind these issues and then select the correct corrosion prevention method. Thank you for watching this video, and see you in the next video. Thank you.